Today's video is going to be about acids and bases in chemistry. Let's do a review of acids. The Arrhenius definition of acids are compounds that ionize to produce hydrogen ions. The Bronsted-Lowry definition is that acids are a proton donor. The Lewis definition is that any substance that can accept a pair of electrons. An acid generates hydronium ions. Acids are corrosive in nature, good conductors of electricity, they have a pH less than 7, and when reacted with metals they produce hydrogen gas and are electrolytes in aqueous solutions. The lower the pH value, the more acidic the substance is. Acids also react with bases to form a salt in water. Factors that contribute to the strength of the acid is the polarity of the molecule and the strength of the HA bond. The more polar the molecule, the weaker the HA bond, and the more readily the proton will dissociate in the solution. Some examples of acids are HCl and HNO3. Moving on to bases. The Arrhenius definition of bases are compounds which ionize to produce hydroxide ions. The Bronsted-Lowry definition of bases is that it's a proton acceptor. The Lewis definition is any compound capable of donating an electron pair. Bases have a soapy texture when touched and generate hydroxide ions. In aqueous solutions, bases are good conductors of electricity. The pH value for bases are greater than 7. The higher the pH, the more basic the substance is, and then the concentration of hydroxide ions increases. Examples of bases are NaOH and LiOH. A neutral substance has the same amount of hydrogen and hydroxide ions. It does not have any acidic or basic characteristics and the pH is 7. Some examples are water and common salt. Electrolytes are substances that dissolve in water and can collect electricity. They are metals, ionic compounds, acids, and bases. Conjugate acid and bases. Conjugate acids are formed when a proton is added to a base. A conjugate base is formed when a proton is removed from an acid. For a conjugate acid, add 1 H to represent adding a proton, and add 1 to the overall charge. For a conjugate base, subtract 1 H to represent losing a proton, and subtract 1 from the overall charge. An acid plus a base yields conjugate base, and conjugate acid. Some examples. HF is the conjugate acid of F, and F is the conjugate acid of conjugate base of HF. Neutralization reaction. An acid plus a base yields salt plus water. This reaction neutralizes the acid and the base. The resulting solution will have a pH of 7, which is neutral. The salt could be soluble and dissolve in the solution, or it could be insoluble and precipitate out of the solution. In a neutralization reaction with a weak acid or base, the resulting solution does not usually have a pH of 7. A salt and water will still be produced. If the neutralization reaction has a weak acid and a strong base, the pH will be slightly over 7, meaning that the solution will be basic. Moving on to titration. Titration is used to discover the concentration of the acid or base. The formula for titration is the molarity of the acid times the volume of the acid equals the molarity of the base times the volume of the base. Here's an example problem. What is the concentration of sodium hydroxide basic solution if 250 milliliters of 0.76 molarity H3PO4 are needed to neutralize 30 milliliters of the sodium hydroxide solution? So then we can see that 0.76 molarity is the molarity of the acid, and then we need to find the volume of the acid, and it gives us that it's 250 milliliters. Then moving on to the base, it gives us the volume of the base, which is 30 milliliters, but doesn't give us the molarity of the base, so that's what we have to figure out. We can set up the equation as 0.760 moles times 250 milliliters equals the molarity of the base times 30 milliliters. Once you do the math, the molarity of the base equals 6.333. The pH scale. The pH ranks solutions according to how acidic or basic they are. Anything below a pH of 7 is acidic, and anything above a pH of 7 is basic. Anything with a pH of 7 is neutral. When the pH level decreases by a value of 1, this means that there are 10 times as many hydronium ions in the higher pH value. When the pH value increases by a value of 1, this means that the concentration of hydronium ions has decreased by tenfold. If you were to write the amount of hydronium ions in a solution with a pH of 3, you would write square brackets H plus equals 1 times 10 to the power of negative 3. If you were to write the amount of H plus ions in a solution with a pH of 5, you would write square brackets H plus equals 1 times 10 to the power of negative 5. For these two pH values, the solution with a pH of 5 has 100 times less hydronium ions than the solution with a pH of 3. This is because each increase in the pH value by a value of 1 decreased the concentration of hydronium ions by tenfold. Since the pH value is increasing by 2, 10 to the power of 2 equals 100. Common acid-base indicators. This is Table M from the reference table. Indicators turn a certain color depending on the pH of the solution. So if we take a look at methyl orange, it says that the range for the color change is 3.1 to 4.4. So if the indicator was placed in a solution with a pH of 3, the indicator would turn red, because in the color change column it says red to yellow. But if the indicator was placed in a solution with a pH of 6, the indicator would turn yellow because it's above the range of 4.4. Moving on to some practice questions. Do the questions and pause the video, and then when you're ready to go over the answers, resume the video. Which substance is an electrolyte? HCl is the only ionic compound here because it contains a metal and a nonmetal. And if you remember, electrolytes have to be metals, ionic compounds, acids, or bases. One acid-base theory states that a base is a C, H plus acceptor. This is according to the definition of the Bronsted-Lowry theory, which states that an acid is an H plus donor and a base is an H plus acceptor. As more NaCl is dissolved in a solute, unsaturated NaCl aqueous solution, the conductivity of the solution increases as the ion concentration increases. NaCl is an ionic substance, and when it dissolves, the ion concentration will increase. Because it is an ionic compound, this also means that it is an electrolyte, so it will be able to conduct electricity as it dissolves. Here are the next two practice questions. Which substance always forms when our arrhenius acid reacts with an arrhenius base? The answer is D, H2O. H2O will form because an acid plus a base yields a salt and water. None of the other options are a salt because they are not ionic substances, which means that H2O is the only reasonable answer. What color will litmus turn when added to an aqueous solution with a pH of 9? Litmus will turn blue because the range of litmus is 4.5 to 8.3 and the color changes red to blue. This means that when added to an aqueous solution with a pH less than 4.5, the indicator will turn red, and when added to an aqueous solution with a pH greater than 8.3, it will turn blue. Here it's being put in an aqueous solution with a pH of 9, so that means that the answer will be blue. Here is the next set of practice questions. Solution A has a pH value of 7, and solution B has a pH value of 10. How many times greater is the hydronium ion concentration of solution A than the hydronium ion concentration of solution B? The answer is C, 1000. Solution A has a hydronium ion concentration that is 1000 times greater than solution B because as the pH value decreases by 1, the concentration of hydronium ions increases by tenfold. Since the difference in the pH values is 3, we need to do 10 to the power of 3, which equals 1000. In a titration, 10 milliliters of 0.0750 molarity HCl is exactly neutralized by 30 milliliters of KOH of an unknown concentration. What is the concentration of the KOH solution? We need to use the formula for titration, which is Ma times Va equals Mb times Bb. So we can set this up as 0.0750 m times 10 milliliters equals the molarity of the base times 30 milliliters. When you do the math, you will find that the molarity of the base is equal to 0.0250 m. Here are two more practice questions. Which equation represents a neutralization reaction? A neutralization reaction is an acid plus a base yielding a salt and water. So looking at the four equations, only choice 2 and choice 3 yield water. And then we need to look at the other products. The products of the equation in choice 2 is CO2, and the product of the equation in choice C is CaSO4. The answer is going to be choice 3 because it has CaSO4. CaSO4 is a salt because it includes a metal and a nonmetal, but CO2 includes two nonmetals. Given the equation representing a reversible reaction, according to one acid-base theory, the two H plus donors in the equation are, they're going to be CH3COOH and H3O plus. In order to determine which reactants are donating the H plus, we need to look at how the reaction will continue each way. Looking at it starting on the left, CH3COOH will donate its H because it loses the H on the product side of the equation. Looking at the reaction starting from the right, H3O plus donates its H because it loses it on the product side of the equation. This makes the answer choice 2. The table shows the molar concentrations of hydronium ions in 4 different solutions. Which solution has the highest pH? The answer is choice D. When solutions have a higher pH, they become more basic. Therefore, the concentration of hydronium ions will decrease. The answer should be the one with the least amount of hydronium ions, which is choice D. Which solution is the best conductor of an electrical current? The solution that will best conduct the electrical current is the solution with the highest concentration because there will be more to dissolve in the water, so more charges will be produced. This makes the answer C, 0.1 mole of NaCl dissolved in 1,000 milliliters of water. Why is potassium nitrate classified as an electrolyte? Potassium nitrate is classified as an electrolyte because it releases ions in an aqueous solution. This is just a simple definition of an electrolyte, so it's just something you have to remember. When the concentration of hydrogen ions in a solution is decreased by a factor of 10, the pH of the solution has increased by 1. When the hydrogen ion concentration decreases, the solution becomes more basic, which means that its pH will increase. It will increase by a factor of 1 because each pH value is equal to a factor of 10, so by 10-fold. The concentration of which ion is increased when LiOH is dissolved in water? A. Hydroxide ion. The concentration of hydroxide ions will increase because LiOH is a base, and bases contain hydroxide ions. This is the final practice question. Which statement explains why 10 milliliters of a 0.50 m H2SO4 aqueous solution exactly neutralizes 5 milliliters of a 2.0 m NaOH solution? The moles of H plus equals the moles of OH. In a neutralization reaction, the moles of H plus need to be equal to the moles of OH because acids contain H plus and bases contain OH. In a neutralization reaction, the amount of H plus and OH needs to be cancelled out in order to yield a solution with a pH of 7, which is neutral.